I am Anil Kumar. Welcome to my video on transformation of functions. In this video, I am going to discuss in details all about transformations. We are going to cover all these topics: reflection on x-axis, reflection on y-axis, vertical stretch and compression, horizontal stretch and compression, vertical translation, horizontal translation, combination of all the above, and based on that we'll have communication thinking questions and multiple choice questions. What you need to know, that's kind of very important to understand. You need to know basic parent functions. So I'll provide you with my link on parent functions. You should know how to sketch the parent functions. We'll extensively use three parent functions in this particular video. One of them is parabola, which is x squared. The other one we'll take as square root function. Then we'll take 1 over x, reciprocal function. The graphs of these functions are, let me draw them here and write these functions. This is the parabola y equals to x squared. Then we'll do the square root function and then 1 over x. Now these three functions actually are good examples, since in the first you see domain has no restriction, however range has instruction. Range is always greater than or equal to 0. In the second one, as you can see, which is square root of x, both domain and range are restricted. And in the third one, reciprocal function, we have vertical and horizontal asymptotes. So these are the asymptotes. So both domain and range are restricted just by the value of these asymptotes, right? So domain cannot have x equals to 0, range cannot have y equals to 0. So these are three parent functions. At times we can extend to absolute function, which is very similar to parabola, right? So that is absolute function, right? So we might take an example on absolute function also. Now when we say transformation, basically we are changing the orientation basically some way or the other. So first change is orientation is changed. So that is reflections, right? So reflections basically lead to change in orientation. Now when we talk about, so this is the first two. Then the next two, which we are saying as stretch and compression, in this shape changes. So in the first two, orientation changes. It could be up or down, left or right. Whenever we say vertical stretch and compression or horizontal stretch and compression, this shape changes. And then the third category is translation, in which case position changes. So that is what you need to focus on. Now we'll also look into how, if we have original points as x and y, let's say this is point P, then after transformation, what is the image? So what is P x dash y dash? That is what we'll be focusing on, right? How the points changes, apart from the graph where orientation, shape or position may change, right? We'll refer to that point as, this one we'll call original point, and that will be treated as image. So with this brief description, let us begin and look into these functions one by one. First, reflection on x-axis. Now, we'll consider f of x as original function. And g of x as transformed function. Okay. So when I say reflection on x-axis, then basically the transformed function g of x will be equal to, reflection on x-axis means y value becomes negative, right? Or y value changes. So it is equals to minus of f of x. Now if that is the change, then the points will change from xy to the y value becomes negative, x negative y. Now let us see how this change affects our parent functions. So again I will draw three graphs. I'll take any three of those which we discussed. So if we have a parabola, let us say which is x squared. So we are saying that f of x is x squared. You get my point, right? Then we'll take the square root function and let's take 1 by x. So basically, when we write the transformation, which is g of x equals to minus of f of x, it really becomes g of x in this case will be what? It will be minus of x squared, correct? Minus of f of x. So that basically means all the values which were positive will now become negative. So it kind of reflects like this. So it's a mirror image. So reflection on x-axis. This is your x-axis on which it is going to get reflected. Now you can actually pause the video and show the reflected graphs for the others. Square root function will be kind of like this. So we are sketching minus square root x. And here, this portion which is decreasing all the way in quadrant 1 will now be reflected and will become increasing all the way as shown here. And this portion will get reflected on the x-axis and look like this. So this is minus 1 over x, correct? Earlier we had sketched 1 over x. So if the function we add negative in the beginning, it becomes reflected on x-axis as shown here. If you're considering points, let me take the function here, which is square root function. So if you're plotting points, you could actually show it like this. That on the function which is square root x, your points could be 0, 0, 1, 1, 4, 2, 9, 3, right? But when it is reflected on the x-axis, these points will change from the y values become minus, right? So 0 remains 0, however, 1 becomes minus 1, and the y value 2 switches to minus 2, and 3 becomes minus 3, right? So you can see here that this point, which let us say was 4, 2, now has a value minus 2, right? So you see the reflection. That's what I mean to say, right? So a point which was 1, 1 will now switch to 1 minus 1. Let's say this is 1, 1 here, right? That's what we're trying to say. And a point which was, let us say, 1, 1 here will become 1 minus 1 in the reflected graph. So I hope that concept is clear to you. That's what we mean when the graph is reflected on x-axis. You could have an expression which is kind of shown here. So as an exercise, you can sketch graph of minus absolute value of x, right? So it'll be like a parabola but absolute function. So that's a question for you to do, right? Let's move on and now see reflection on y-axis. Reflection on y-axis means what? Let us first sketch and then we'll talk about it. So if I have square root function, now this is y-axis for us. This is x-axis. Reflection on y-axis means that all these points will get reflected on this side, so we get a graph which will be kind of like this. Do you see that? So a point which is, let us say, xy has been changed to, the x value becomes negative. Do you see that? Minus xy. So that is the transformation which takes place, right? If you're working with square root function, in that case, now coordinate 1 will be seen in coordinate 2. Well, the result is kind of similar to what you saw last time, but the changes reflection on y-axis. That is kind of important to understand, right? So this is your function, which could be written as 1 over, we'll write minus x in brackets. You get my point. Here, we'll write this as square root of minus x. So, minus is within the square root sign. Now let's look into the parabola. Now this is even function. Now this is very typical. When I reflect this side on the other, it kind of overlaps. Do you see that? And reflection of this, let me use another ink just to show you that the reflection of the left side overlaps the right side. So end result is kind of same. Well, that is expected, since what we are doing is we are doing minus x whole square. You get an idea, right? We are doing minus x whole square, which you know technically is equal to x square. So both the graphs match. You get an idea, right? So that is how the graphs can be shown on after reflection on y-axis, right? Now in this particular case, you see that g of x, which is f of minus x, for a parabola, it is kind of same, right? So when you have something like this, we say reflection on y-axis. Now in this particular case, what we notice is that f of minus x is equals to f of x. We say the function is even. Now that is a very interesting property. If f of minus x is same as f of x, as we have seen just now, we say that the function is even. So that's another thing to remember. Now, getting back to this definition here, what we see here in the case of a reciprocal function, however, we see that f of minus x is equals to minus of f of x, right? This is same as minus of f of x. So reflection on x-axis is same as reflection on y-axis. These kinds of functions will be called as odd functions. Odd symmetry, or we can say odd symmetry. Let me write symmetry. We'll say even symmetry. Well, this has neither. So So when we talk about reflections, we can also see whether a function has odd symmetry or even symmetry, right? We'll get back to these topics once we do combination, but I'm just giving you overview at present. Now we'll discuss vertical stretch and compression. The function g of x is said to have vertical stretch or compression if it is written like a times f of x. Now depending on the value of a, it could be vertical stretch or vertical compression. So if a is greater than 1, then we say it is a vertical stretch by a factor of a. That means all y values will get multiplied by a. If the value of a is between 0 and 1, right? In that case, it will be a vertical compression by a factor of a, right? So that's the meaning. As far as the transformation of points is concerned, if on a function f of x, we have a point x, y, then on the transformed function g of x, this point is going to be, x value remains same, however, y value gets multiplied by a, right? So if a is greater than 1, it increases, right? If a is between 0 and 1, it decreases. So that is the compression part. So I hope that transformation is clear. Now let me show you with the help of our examples. So let's take parabola as first example. Now normal graph of the parabola may look like something like this, where this function is x squared. Now consider the function g of x to be equal to, let us say 2 times x squared. So when I say 2 times x squared, in that case, all these points for the same x value, the y value doubles up. So this value will become twice. Let's say it is 1 here, it will become 2. 0 remains at 0. So 0 is invariant, it will not vary. The point here, let's say 2 square is 4, it becomes 8. So it gets multiplied. So the result will be a stretched graph, kind of like this. Do you see that? So that is going to be the graph of 2x squared. So basically, what you notice in this case is that the points which on the original functions are kind of, let's say 0, 0, 1, 1, 2, 4, these will get transformed into 0, 0 remains 0, 0. 1, 1 becomes 1, 2. The y value doubles, right? So 2, 4 will become 2, 8. Do you get the point? That's what we mean when we say a value multiplies into y or by a factor of 8. Do you see that? Of course, the negative values will also go in the same fashion. So I hope that part is absolutely clear. Let's do it once again for square root function. So let us say this is the square root function where we have points like 0, 0, 1, 1, 4 square root 2, and square root of 9 is 3, like this, right? Let's say these are the points on square root of x. Now, the points on 2 times square root of x, which is the transformed function, will be y values gets multiplied by 2. You get the idea, right? So it will become as shown here. 3 times 2, 6. So the y values 0, 0, let's say 1, 1, it gets multiplied. For same value of 1, we get 2 instead, right? So for 4, if it is 2, it'll double up. So the graph will look like kind of like this. So each point gets stretched by twice its original value. That's what we mean when we say vertical stretch. So I hope you understand it, right? Now, what I will do here is I'll combine our previous learnings with current. So let me now take a function which is kind of y equals to, or g of x equals to, minus half x squared, right? Now, when I say minus half x squared, we have done two transformations here. The first one, minus, means it is reflected, which we learned earlier. So let us try to sketch this graph here. So original graph of x squared will look like this, right? So this is the x squared graph. Now when I do minus half, minus means it gets reflected, right? So first part, let's look into minus, which is reflection. So it just gets reflected. That means we are sketching minus x squared, right? That is a reflection. Now, compression by a factor of half really means that all these points will be halfway down, right? So they get multiplied and they will come here. So we'll have a final graph which will look like this. So this graph will be minus half x squared. You get an idea. So here we have combined reflection with stretch, right? So we have done two things here. One is reflection on x-axis, and second is compression by half, vertical, right? So two things we've done here. So I hope the concept is clear. So we'll move along and carry forward our learnings. Now let's look into horizontal stretch and compression. Horizontal stretch and compression could be represented as g of x equals to f of kx. Now this factor k results into horizontal stretch or compression. Now in this case, if k is greater than 1, in that case we have horizontal compression by a factor of 1 over k, right? What I'm trying to say here is that if I have an equation which is g of x equals to square root of 2x. Now here you can see it is inside the function, right? Inside the function. K is greater than 1, it is 2. That means it gets compressed horizontally. Let me show you how. So we'll sketch square root function, the base function which is, let us say, square root of x. Now g of x, which is shown here, square root 2x, compression by a factor of half in this case, because k is 2, which is greater than 1, basically means every point, let's say this is at 1, it will shift halfway down and come to half. Let's say this is at 4, then it's going to shift halfway down, and the graph which results is kind of like this. You get an idea, right? So in this case, what really happens is that the points which were, let's say, 0, 0, 1, 1, 4, 2, and 9, 3, that's the square root function. This is for square root of x. Then for square root of 2x, these points will be 0, 0 remains 0, 0. However, 1, 1 becomes, the x value becomes half. Y remains same. So that is what we mean when we say horizontally shifting left, right? Do you understand? In this case, half of 4 is 2, but we get the same y value 2 at 2 instead of at 4. And here at 4.5 we'll get 3. You get an idea. So in this case, the transformation is basically any point which is xy will get transformed into 1 over k times x and y remains same. Since only horizontally it is affected, you get an idea, right? Now if k value is less than 1 but greater than 0, in that case we'll have horizontal stretch by a factor of 1 over k. Let me give you example here now. So let us take parabola this time. Let's say y equals to x square. Now these are good and simple functions to consider, right? Now what I'm trying to say here is the factor is 1 over k. We'll keep this as half. So let's say it is 1 over 2 x whole square. So we are considering the function g of x equals to f of half x, where f of x is equals to x square. You get my idea, right? So x square, x is replaced by half x. Do you see that? That results into horizontal compression. So this is horizontal compression by a factor of half, right? So we write like this. We write this as, I'm writing it here, horizontal, since it is less than, right, horizontal stretch by a factor of 1 over 2. So horizontal stretch by reciprocal of 1 over 2, right? So it becomes 2 by factor of 2. You get my idea. So a point which is, let us say, origin remains there. So the point which is 0, 0, let's say we'll consider the points on the parabola first. Then what really happens is that the x values double up. So for 0 it remains 0 times 2 is 0. And here it becomes 2, 1, 4, 8, 4, 4. 3 times 2 is 6, 6 and 9. So the points, now if this was at 1, it stretches, means that is what we mean by horizontal stretch. So this point which is at 2 stretches and goes to 4. Do you see that? So the parabola will now look like this. So horizontally stretched, you get an idea, right? Both sides. So that is what we mean by saying horizontally stretched. One over 2, which is 2. Do you see that? 1 over 1 over 2, which is 2. So it becomes wider. Do you see that? So it becomes wider if the value is between 0 and 1. So I hope that concept is clear, right? We'll combine all this soon and then you'll get fairly good idea of what we're talking about. But I think from the points, transformed points, it is making sense, right? Let's move on and take vertical translation. In general, we could write if f of x is our function, then g of x could be equal to f of x plus some value, right? Let's say plus c. Now c is the value by which it translates up and down. So if c is greater than 0, that means positive. In that case, translates up by c units. If c is negative, right? If c is less than 0, that means negative, then it will translate down by c units, right? Let's take example. Let's take a function g of x as absolute value of x minus 2. And let's take another function g of x as, we'll take combination this time, minus square root x. So that is a reflection. And then we'll do plus 1, right? So we'll sketch this function also. So let's try them out. You can actually pause the video, sketch yourself, and then compare with my results. So absolute x function is basically kind of like this, right? Now when I say absolute x minus 2, this is absolute value of x. I'm bringing every point down by 2 units. Do you understand? I'm bringing every point down by 2 units. So it will be like this, right? So where this point is minus 2. So that is what it results into, correct? So this is your g of x. Absolute value of x minus 2. So pull it down by 2 units. As far as the points are concerned, any coordinate point x and y will now become, x remains same, but y value becomes less by 2. That's what it means, right? Or less by c, you can say, right? Plus c, you could say that. For this particular function, less by 2 units as shown here. Now can you sketch this function? Here we have two combinations. One, let's say we have a square root function. First is this negative, which means reflection on, now this outside negative means on x-axis. X-axis. Is it okay? And now we have plus 1, which means translate up by 1 unit. Is it okay? So first step is reflection. So what we will do here is we'll reflect this graph on x-axis as we did in the very first video, first part of this video. And then second, we'll move everything by 1 unit up. Do you see that? So if you move everything by 1 unit up, it will be kind of like this. Now that will be the function minus square root x plus 1, the g of x. You get an idea. So we have two transformations here. One because of reflection, that is 1 written here. The second is because of translation, which is moving up by 2 units. Correct? Now we'll look into horizontal translations. G of x equals to f of x minus d. Now when you have something like this, then if d is greater than 0, then it translates the graph d units right. But if d value is negative, that means less than 0, then it will translate the graph d units left. Let's take example. So what I will do here is first sketch and then write down the equation. Is it okay? So let's say we have an absolute function here and we have square root function here. If I translate this left, let's say, right, kind of like this, to a position which is minus 2, then can you tell me the equation of this graph? It should be square root of x. We went to this side, square root of x plus 2. So if I write minus 2, you get 0. Do you understand? That is what we're trying to say. So square root of x plus 2 means d is minus 2, less than 0, translates left. Do you understand? And in this case, let me do two transformations. One, let's shift it kind of like this, where the point given to us is, let's say, 3 minus 1. Then can you write down the equation of this transformed function, knowing that the original was absolute x? Now here we moved down by 1 unit y value and moved right to 3. So I could write this function as absolute value of, so you're moving right by 3 units, we'll write x minus 3. That makes it 0 at 3, right? And down by 1 minus 1. So that becomes g of x as shown here. So this is the function which is 3 units right and 1 unit down. And both are translations. So what you'll observe here is that in translations, position changes. So here only position changes, right? Just a reminder. In stretches and compressions, shape also changes, right? Okay. So I hope that gives you a good combination of all the things which you've learned. And it's time for us to review all of them combined together. Let me combine all what we have learned here. So now we'll write a function g of x as equal to a times f of k times x minus d plus c, right? So this is the ultimate equation which combines all the transformations we have learned so far, right? Now to summarize, we can look into it like this. This is the inside part which is for horizontal. And the outside part is for vertical. Correct? Now, A will give us vertical stretch or compression. So if A is greater than 1, it means vertical stretch. If A is greater than 0 but less than 1, then it means vertical compression. Correct? If A is less than 0, I mean negative, right? It means reflection on x-axis. On the other side, on the vertical side of C, if C is greater than 0, it means up. And if C is less than 0, it means down. Translations. Correct? Now here let's look into K. Horizontally, if K is greater than 1, we say horizontal greater than 1 is compression. Kind of reverse, right? By a factor of 1 over K. But if K is less than 1 but greater than 0, then it is horizontal compression, stretch, right? By 1 over K, right? That's kind of important to understand. Now what happens when K is less than 0? Means K is negative. It means it is reflection on y-axis. We're left with D. If D is greater than 0, it means we have to translate right by D units. And if D is less than 0, then we have to translate left by D units. You get an idea, right? So that is the summary, which kind of gives you everything together, right? So I hope it makes sense. Now let's take up some test questions. Here is a communication and thinking question for you. Now this is a very tricky question. We need to sketch graph of g of x which is given to us as 2 times square root 6 minus 2x minus 4. Let's rewrite this function first. We are given g of x as equal to 2 times, that is a vertical stretch. However, within the square root, it is good to write x in factored form, right? So let me rewrite this as first rearrange 2x plus 6 minus 4. Now, it's a good idea to factor minus 2. Then you get x minus 3 here, minus 4. So actually the function should be seen as we are writing now, correct? So I hope you can compare it with your general expression, which was g of x equals to a times f of k x minus t plus c. Now you will notice that k is factored, right, from x. X coefficient is 1. Do you see that? So this is the k value. You get my idea. So only if you factor, you get the right transformations. So in first case, I'll write the transformations. When you combine all the transformations together, you have to follow a proper sequence, right? Important. Follow a sequence. Basically, it means product first, then add or subtract. You get an idea. That means translations, right? Or what you could do is, in short, you can go from left to right. That is always a correct sequence, right? So let's look into our transform function, which is, let me rewrite, g of x equals to 2 times square root of minus 2 x minus 3 minus 4, right? What does this mean? Now this 2 here means, let me write in a different thing. This 2 here means reflection. There's no reflection here. This is vertical stretch outside, right? By a factor of 2. That's what it means. Now within the square root, we have the square root function, and this negative here means reflection on y-axis. Then minus 3 means translate 3 units right. And minus 4 means translate 4 units down. Do you get it? So these are the transformations which we need to incorporate to sketch the function. Right? So we need to vertically stretch by a factor of 2, reflect on x-axis, y-axis, reflect on y-axis. Now this I forgot to write about 2. Horizontally compressed by a factor of half. Let me add here before translations. I forgot this 2. Okay. So which is horizontally compress by a factor of half. This is for this 2, which I forgot. Okay. So these are all the things which you have to do to get to the graph. Now let's talk about how the points will change from original to the image. Translation of the points is kind of like this. X, Y will change to, as far as X is concerned, it will get multiplied by negative half, that's the factor, negative half of X, and then you add 3, moving 3 units right. As far as the Y points are concerned, they get multiplied by 2 and then you take away 4. So that is the transformation of the points. Okay. So you could actually calculate the points and also sketch. You could do that. Now, as far as the graph is concerned, what I will do is I'll make a small graph here to show you how it should be done. We'll make approximate diagram. This is my square root function. When I say stretch by a factor of 2, let me use this color for 2, means every point moves up, right? So it becomes, this is your stretch by a factor of 2. You get an idea. Now, the next portion as you move in is this negative. So this negative here means reflection on the y-axis. And then we have 2. That means we have to compress it by a factor of half. So if you compress it, actually, it becomes more steeper. So these points come halfway down. So it will be actually more steeper. So this is my compression by a factor of half, step 3. Now we have minus 3, that is to say that we are going to translate it 3 units to the right. So this graph is now translated 3 units to the right. So that is my graph number 4, translating 3 units to the right. And finally, I'll sketch the graph bringing it down by 4 units. So bringing it down by 4 units, so it could be kind of like this. Do you see that? Where this point happens to be at 3 minus 4. Do you get an idea, right? So that becomes your transformed graph of square root function, very much stretched, right? So that is how you could sketch it. As far as the points are concerned, in this small space, let me write down the points also. Okay, so what I will do here is, I'll write down the original points which are on this graph of square root x as, let's say, 0, 0, 1, 1, and let's take 3 points. Now, as far as the x values are concerned, we are doing minus half and then plus 3. So here this point becomes minus half times 0 is 0, but we get 3 here. As far as the y value is concerned, we'll multiply by 2 and then do minus 4. So we get minus 4, correct? Which is this point. Do you see that? Now next point is 1, 1. Minus half plus 3 gives us minus half plus 3 gives us 3 minus half, right? 3 minus half, which is 2.5. So it gives us 2.5 for x. As far as y value is concerned, it gets multiplied by 2. So we get 1 times 2 as 2, minus 4 gives us minus 2. So we get some value here, which will be that value. And the third point, half of 4 is 2 with the negative sign minus 2 plus 3 gives us 1. And y value gets multiplied by 2, so we get 0 here. So that is this point. Do you understand? So these 3 points are shown on the graph. You could actually make table of values as shown here and sketch your function. You can use this method of finding image points. So these are your image points. And then you can sketch, right? So I'd like you to calculate for 9 and 3 and then put that point on the graph. So I hope that helps. So we have combined all the transformations together and sketched one. Now, let us take up multiple choice questions based on transformations. I would like you to pause the video, look at this transformed function, and then answer. Question is to match equation with the given graph. Here is a graph of a square root function. You know, normally it would look like this, right? Now it is looking like this. Now, which of these equations fit for the given graph? That is what you have to make out. Now, minus means reflection on the y-axis, and plus 3 means moving it up. So it shows the shape. So plus 3 is okay. Now this point is at 1. That means we have moved it 1 unit to the right. Right? 1 unit to the right. And we have also reflected it on the y-axis. So if you write down the transformations, what we have done here is we have reflected on x-axis and also on y-axis. Right? We went down and then flipped it. We have done both the reflections, and what we have also done is we have, if you see this point and 1 point above, it's only decreasing by 1, so 1 1 is still 1 1. So there is no horizontal stretch or compression. However, there is a translation. So we have translated from 0 a point which is horizontally translated 1, so 1 unit right, and 3 units up. So which one will show you 1 unit right? We are looking for one of these two. Now these two reflections perfectly match. Which one is the right answer? Now let's try to write in factored form. This one. We get minus square root. So this is minus x minus 1. Do you see that? Plus 3. The other equation here is minus square root x plus 1 plus 3. Now this means reflection to left. This means reflection to right. Perfect. So as per the reflection, we get option B as the right option. You get an idea, right? So that is how you could match it. I hope it makes sense. You could also substitute value 0 and calculate. You will get 2 as the y-intercept. Let's take the last question now, which is based on reciprocal function transformed. So what we have here is a reciprocal function transformed. Can you match equation with the given graph? Pause the video, answer, and then look into my suggestion. Now here, critical point is to observe asymptotes. So what we notice here is that vertically we have shifted 1 unit up, right? So 1 unit up. And as far as horizontal things are concerned, we have moved 2 left, 2 units left. Correct? So we are looking for x plus 2, which matches. And 1 unit off means 1 has to be positive, right? So one of these match. Another thing which we note here is that normally 1 over x would be kind of like this, right? This is your 1 over x graph. But it has been flipped. It has been flipped. That means we're looking for a negative sign. Is that right? So we're looking for a negative sign and a translation. So A matches 1 unit up, reflection, correct? And also 2 units left. So A matches. So at times it could be very tricky. You get my point, right? Now here is a question for you. Your question is write domain and range for all g of x, transformed functions, right? So for this function, write domain and range. Get back to our previous one, which is right here for you. So I'd like you to write domain and range for this function also, right? You can clearly see domain is, now here domain d of x is x belongs to real numbers, where x is less than equal to 1, right? As far as the range is concerned, y belongs to real numbers, where y is less than equal to 3. So likewise, try to write domain and range for the functions we have discussed in this video. I think that will help you to understand transformations even better. I hope it makes sense. Feel free to write your comments and share your views. And if you like and subscribe my videos, that would be great. Also follow the connections or the links which I have provided for extra practice. Thanks and all the best.